ease that immediately. But the SEG does what the body cannot do. It emits Good evening, everyone. Thank you for spending your time with me. And I hope at the end of the show, you'll find it worthwhile to drop in. I'm only going to borrow your ears up to 3 o'clock, and I'll give them back to you at the end of the show. We have John Thomas from Rochester, New York. He's been helping me for a few years. Some of the team, unfortunately, have had to take a flight home today. But we do have... Russell. Yeah. Russell. Yeah.
Russell.
Russell, yeah. We have Russell who is now in charge of the flight. You don't know his first name. He's now been made in charge of redeveloping the IGV. And this has been done in the USA. The two people are USA, and behind us we have a great lady, Princess of Energy. America, she's been doing hard work to get massive publicity in the USA. And through her, I am here today. We have more people like this. We would have an SEG on the marketplace in a very short time. Once we got a site and the money is in place, I guarantee in 12 months we will get this new arrangement and make an SEG that can be mass produced. And when we do, America will be clearly the first country in the world to use the SEG. It is a hard job for an inventor to be able to succeed on this planet. There are too many oppositions. 3 days before here, attempt was made to stop me coming here because they wanted me to sign a paper for them to own it and take over. This is what's happened all through life. Just as I get to the top of the hill, they steal all equipment to stop me getting on the marketplace. From today onwards, we will stand strong, and no one will be able to force us to hand over the control or stop. It is go, go, go. Now, you may wonder, what good is the SEG to you? First of all, health. The wife in the kitchen, cooking, scolds her hand. I've done that often, so I know. It stings, it gets red. Your body cannot cope with that and ease that immediately. But the SEG does what the body cannot do. It emits very strong, powerful negative ions. That, within seconds, cools the hand, and in minutes, the red signs are gone. That would be a blessing, I think, for every wife on planet Earth. The next thing is, in the home, you will have the room at negative charge, not positive charge as it is now. In positive state, dust rise. The dust carries viruses and bacteria, and you inhale them, so that you offer them away for a nice, comfortable meal. The SEG negatively charged, the dust falls to the ground. So all your friends are on the ground, and you can just go and backen them up. That alone, I think, is a blessing for most families. Also, there's another interesting effect. You'll find that as you breathe, you think you're drinking fresh spring water. It is an unbelievable taste that you get. I know that people in the home may have lots of complaints about electricity, high electric bills. Just think for a few minutes. SEG, no bills. You hand down your home to your family, and still no bills. And they hand it on and hand it on. Now, should you want to move to another place, a new building, you can take the SEG out and stick it in that place, and away you go again. That must be a blessing today. The oil spill in the Gulf should never happen, because in 1968, if the project had gone to the marketplace, the SEG would have been in America in any case, and that well would never be needed to be drilled in the first place. On top of that, your car. You're paying a high price for your fuel. You're creating pollution. Why? because the SEG in the car creates no pollution. You get in, turn the key, and away you go, regardless of the weather condition and how far you go. There's nothing. You can say bye-bye to the petrol stations and you go on your way. You may say, how fast can you go? Well, I'll assure you that the generator we will make for the car will tear you up a hill faster than the car you've got now. And that's the issue I would bring up. We want in America to build the car with the SEG. The target is to drive from east to west and back to east non-stop. I don't think there's another vehicle on the road that can do that. And I have placed John Thomas in the task of raising money, finding a firm that sells the cars that we can meet and try to see if there are suppliers of car to fit an SEG in. And I'll have talked to one or two companies. The interest is there, but the problem with them is that they worry about the government. Let me make it clear. I have not a minute of worry about the government. We have the FBI, to John Thomas, and he's told them what they do, and they order the first 2 machines off production line when we go into production. Is that correct?
Oh, yes.
So the FBI is no trouble. And in fact, all my broadcasts this year have invited security, Army, Navy, Air Force, government officials to come through the front door, shake hands and have a cup and we'll have a chat. There is no closed door to them. Therefore, there's no feeling in me that there's any threat of stopping this work. In fact, they really want it because of the pollution factor. If we don't cut that pollution down, our children are going to suffer. And that's the last thing I want to see. I'm here to try to get you together and do it. It's a project for the people, not for a small group. It's a people's project, and I want to keep it that way. And I need your help because we have the technology, we have the know-how. The only things that are missing is you and cash. When these 2 are in place, we're ready to go, to give the power to the people. And remember, it's you that's going to make it happen. I cannot do it on my own. I can make 1 or 2. I can make 1 or 2 for use for experiment work because the cost today is shocking. People say, why can't Searl do it now? If he did it in 1946, why can't he do it now? 1946, the SEG cost £108. Today, the rare earth is no longer 20, those few pence that he said, it is now £29.5 plus VAT, 17.5 pence. Now, you add up a kilo and you find you've got a mighty costly project on your hand. What caused it? General Motors. They bought the right to produce the rare earth, and if you don't pay them yearly a fee, license fee, you can't have it cheap. You have to pay through the nose. I feel that if we really got together and get this lab set up, we can get the people behind us, and General Motors will have to supply the near cheaper. At the moment, we're getting it from China. So we have to keep a base in China to get the rare earth, because they're not going to allow rare earth to come into other parts of the world. They need it themselves. So we have really got the ball moving in many areas. Patent, I'll make that point clear, you do not patent the know-how. Because if you do, you're telling everyone how to do it, and people like terrorists would have the perfect weapon to destroy. something that wouldn't cost them anything after they made the magnetizer. And they don't just wipe out next door's equipment, it wipes out many miles of equipment. And you cannot repair it, you have to re-buy new equipment. So you see, I have to secure the magnetic side. Otherwise, the other firms can make the other parts. And I don't know, have we got the old setup there? Mock-up?
Yes, we did.
We have. So you'll be able to see what we want to do, because we push for time, is to throw it up on the screen when we ask somebody to come and do a test. And I think we'll get on with that and get that out the way. So if a volunteer, because I don't want to do the testing, people say he fixed it. Now we want the volunteer who's brave enough to go up and right. Can we have you? Can you let him feel the weight of the plate and rollers?
Sorry, looks like the microphone doesn't work. The SEG is a compact design. It is 50 kilowatt generator, a meter in diameter. It has only a 3 inch line. And it is not turning down. But with that, it has 15 kilowatts there. And that's the smallest you can make.
Should be on. Sorry, go ahead. Try it now.
Test. Oh, great. Thank you very much. Okay, John. Is there anything else you want to add to that?
Everybody's seen it up on screen. Maybe we should go on to the new demonstration we are investigating, and we'll get that off.
Okay, the thing you're seeing rotating right now is another test platform that we just completed, and we haven't had the time to make those critical adjustments that we're looking for that has to do with the SEG. So that's another project I got going on to isolate another particular aspect of the SEG, just like we are with the rest of the demos. And that has to do with the magnetics, a peculiar magnetic arrangement that'll give you more spin than normal, a propensity. And that's what I hope to evaluate within the next month or two. What you're seeing right now is a calibrated pulse. And when you add one pulse, you measure how many turns you got, make adjustments, and if you gain additional momentum, then you know you're onto something. John says, look for a fine line, a peculiar adjustment, and that's something I look forward to.
But you made it. I just, for those that didn't hear before, when the microphone was on, Fernando has made the first ring, the mock-up is an exact duplicate of the first ring. Hello? Okay? This mock-up that he has made represents the first ring of an SEG. It's what the exact proportions would be. Although this one is not an SEG, it shows the function of it and the fact that the rollers will go around without flying off and go around quite fast. It's amazing how fast they'll travel without flying off. So that's about all. You have something more to add?
Okay. Thank you, John.
Can you take the big plate and put a roller on to show how fast it will spin around there and not come off?
You're saying one roller?
Yeah,
Just
just
one
use
roller?
one roller, yeah, and the plate.
In our project, we have to do things in stages. In other words, when we say we had an SEG project, we don't intend to, we're not going to make the whole SEG at once because that requires a lot of resources. But what we can do is build the first ring and the first roller. If it's magnetized correctly, that's all you need to demonstrate the Searl effect. Right now, we were simulating 12 rollers. But at some point in our project, once we're fully funded and we got a lab set up and a good team and all the resources that we need, our first aim is to get one roller to run by itself. And I think that's what everybody wants to see, that sort of thing. But in the meantime, I'm able to isolate particular functions of the SEG, and that's what we can demonstrate here. And then when you put it all together, it starts to make sense. So give me a minute, and I'm going to remove 11 rollers over here so I can show you what we hope to achieve in the future, as John requested me.
Moving all of the rollers but one.
Yeah, just leave one. You can do it, but only needs one to just show that there's no electrical thing regarding the plate and the roller.
Right.
It's effects of the coil attracting it that makes it move.
Yeah, they were.
The field wasn't quite right.
No. You see it?
When it comes to the SEG, John tells me, watch your fingers, because once you place a roller,
Out of there and the roller.
it doesn't accelerate.
Spin around just
It
by
just goes
shaking
at
the
a
wrist.
constant rate.
And-
John has actually experienced blackened fingers because he didn't move them out of the way. In this demonstration, this is what we hope to achieve with just one roller. You don't need all 12, but you do need 12 to have a smooth operation and to complete the full set of rollers. The second one is 22 rollers,
Plate.
and the third, 32.
Roller. No.
If you all saw something like that, how many would invest in it? No problem, right? That's our problem right now, is everybody wants to see it work, but who wants to do the R&D? That's the catch. In order to achieve these things, we have to do the R&D and make it happen. Now, we're very fortunate to have John Searl with us. We should take advantage of that. He has a team. We're ready to work together. Everything is in place. We even have a corporation ready
Plate.
to
One roller.
take on investors and just work like any other product. Research it and do it and bring it to the market. That's how we'll all benefit from it, because that's the way the economy is run. Make it an economical product, put it on the market. We're all better off for it.
I want you to lift up the ring and have the roller and just rotate it with the wrist and show it.
Okay, got it. The nice thing about this arrangement with the SEG is that it stays on track. You saw how the roller will just continue to rotate. That's the motor action. And I think John wants me to lift it up, just show you that it stays on track.
Okay. There. You can tell what you're doing, too. Do you want to tell them what they showed?
Okay, I think that's what John wanted me to show you all.
Yeah, he did.
Thank you. Thank you, everybody.
Good.
I'm going to work on the slides and show what you guys do.
Morris, who's been doing this demonstrations for you, he is the head of the Searl Magnetics Incorporated USA. He's in charge now of in all development of the magnetizer and all the magnetic work to be done. And he is stationed in California, USA. As you see, we're already building up the USA team. Unfortunately, some had to go home today. Many more couldn't make it because they have so much work to do. So you see, we are determined. No ifs, no buts. There's no wires to that plate. We lift it out and we show you the roller spin around it. So our sensors really has nothing to do with that roller. All that's doing is telling us how much voltage is needed to move that roller, that weight. The scientists and experts say that cannot remain on the disc, that plate, because if you move it, it will just shoot off. And if you try to put 12 on, it will shoot off. They are the experts, and we all know how awful the records of experts are. They always get their sums wrong. The bicycle wouldn't work, the car wouldn't work, telephone wouldn't work, and all these things we all know about once was stated as impossible by the experts. You've got them. Take Tesla, he gave you the AC power, and they were blocking him and trying to stop it. But today, nearly everything you use, made by man, using power, uses Tesla's energy, the AC current. So when you hear scientists down somebody, remember, that must be something good. Otherwise, they wouldn't be downing it. We have 3 states in the human race. We have scientists, the experts of yesterday. We have the masses that don't worry about the past that's gone. And they just worry to survive today. And then we have a very thin line called inventors. They're the people who could see ahead. Without them, there would be no change. We would have one standard day like all the other animals, and there would be just season change. But thank heaven for these individuals who don't take notice of the suffering, the agony, and threats, carry on to see if they can prove their point. To them, we thank them. And to Tesla, I know how much he suffered because I have suffered too.
Right. No, I just give you the congratulations.
Now, what we've got to do, or wish to do, to make sure you have had a chance to ask questions. Anyone got a question they wish to ask while we're here?
Right.
No.
Will y'all be covering the law of squares?
Well, the question was, will you be covering the law of the squares in this workshop?
Well, yes, let's, have we got the whiteboard?
Yeah, right here on the podium.
Right. Right. I draw it 4 by 4, your hands more steady than mine.
I don't know where plus the there it is.
Make it as as possible.
Little wavy, but it gives you the idea.
Right, did I stay there? That is what we call a 4x4 squares. Now, we'd like somebody to come up, and I want them to write in any square a 2 number, above 16. Anywhere in the square. Now, who's good at mathematics and can write a number on here?
Here's a fellow asked the question. He's going to do it.
You're brave.
No.
Nobody else seems to want to come up.
Somebody wants to put a number.
A number,
Two-digit.
2 digits.
Above 16, huh?
Right, yes, anything above 16.
Okay.
Right. Here, he entered. Now, I think we can say this man has no idea what I'm going to do, except he wants to see a square done. Right. Black, I think I have.
A black or
Black, yeah.
Right.
All right, let's do a little bit of mathematics first.
Mm-hmm. These squares are shown in his books, a lot of the squares, and it's amazing when you study them. It really gets you thinking in a different way. Kind of to me, it makes you think in a coherent fashion.
All right.
Because things like that, like this, show a reflection of nature.
Basically, the squares are a mathematical representation of the complex switching and exchange patterns between matter and energy that once you know what you're doing, it's really easy to explain this Searl effect technology.
Is anyone time that? Now,
Yeah, about
when you get
100
home,
minutes.
you can copy that now and see if I'm right. What we want you to do is to add each of these 4 horizontal lines and the 4 vertical and the 2 diagonal, and see if each of those lines come to the same value. Then I want you to check that middle one and see if that's the same value. We want you to quarter and see each quarter is the same value. Then I want these 12 values to be added and see if that value comes to 3 times that line value. If I'm wrong, you can come back and give me a good thrashing. So, now you see how quick it is.
Yeah, try to do it.
And you put the number in, I never. That was called a space frame. But that's good enough, and there's a second choice, is what we call time frame, but we need to cover a number of things. Are you all happy?
Yeah, hold it up. Write it down.
Ronnie, yeah?
There, to the camera.
There's a camera here. Which one? Which camera?
And that is done by a man who never had any normal education, so the experts say.
We are. Okay.
No, just give it to him and
Here we go. There we go. You'll get it.
Where's that third one? It's 17, 43, and 12?
14. Or no, not 14. Can't be. What is this one?
That's
Oh, it is 14.
yeah,
Yeah, it is 14.
yeah. Sorry, my fingers are not as good as they used to be. Now, this type of maps, last known use of it was over 5,000 years ago. The question now comes, how did I know how to do them? They're not taught in schools, grammar schools, or university. Some been saying in the press, aliens that told me how to do it. I don't think that's the case. That then the other people said that is passed on from family to family, which looked like the more likely one. The experiments we've done to check that has been proven, but we won't tell you what the experiments we did to prove whether that is true. Now, any more questions?
Could you elaborate on the function of that?
On what?
Could you elaborate on the function of the device spinning?
He wants an explanation of the device that's spinning. Fernando, do you want to give that, or you want Fernando? Fernando, could you give a little more description of the spinning device?
Are we talking about the spinning unit? Okay, that's an experiment that John did back in 1968, which I'm trying to replicate. It was just finished before I left, and I haven't had the time to make the adjustments, but it is finished, it is calibrated. It does have an electronic calibration to it, but there are peculiar magnetic arrangements which I'm trying to explore and check out. It's going to take a lot of note-taking, and I expect it's going to be about a month or two before I can find that change in momentum that John has described to me. And this is not the first time he has asked me to look out for something. The other example would be the magnetization process of developing wave patterns on magnetic rings. I never heard that, and I don't see any references on books. It's just that I took his word for it, and I used my technical skills to do my part. You can't hear me? I'm sorry. Anyway, one of my greatest achievements with this project is that I found that you can impress magnetic waves with a suitable magnetizer. And that's interesting because it ties in with the magnetic bearing, the roller. Why does it rotate? It happens that the asymmetry of the magnetic field that we get from the magnetizer makes for spin on the magnetic bearing over there, which all of you will get a chance to check out for yourself if you haven't already. So right away you see the connection between the rollers and the spin and the magnetization. That's interesting to me. Watch our website, searlsolution.com, and we'll give you updates on what's John called in the past a glass bar. Okay?
You're talking about the rotating thing, right?
Yeah.
Yes. Hard to hear.
Yes.
Is it powered or unpowered?
It is pulsed right now, yes. And what we're looking for is a change in momentum. It's a calibrated pulse. In other words, pulse it once, you get, let's say, 5 turns. We make magnetic adjustments. You can't really see it from here, but there are magnets in there. John says, make the appropriate adjustments, a fine line in there somewhere. And once you got it, you'll get more than just 5 spins. And that's another integral part of the SEG that we will be able to demonstrate. Okay? Thank you.
Is the 12 rollers on this to be able to create 60 hertz required from electricity?
No. Is the 12 rollers configuration used to achieve the 60 cycle frequency?
It would do. We can change that to more if we wish, but for domestic house power, 50 cycles, 60 cycles, we can make the one we are developing fit both requirements. It is how we set the final coils that is going to pick up that energy as the rollers pass by.
And also, there's going to be 2 more rings.
Yeah, there's 2 more rings and two lots of rollers. The first set, this is for the domestic one, is 12 rollers. Then there's 22 on the second. Then there's 32 on the next one. Why? Well, the reason is we've got to build the power up. The first will produce, when it's the SEG type, 3.5 thousand volts. That is fed in the next one. That plate will produce at least 6.3 thousand volts. So we're feeding that in, and this is pushing it up. Then the last plate will give us around 9,000 volts. And with this added, you have got immense voltage. We then have a step-down transformer that just drops it down to your voltage that you're using. Voltage is proportioned to current, or the other way around, current is proportionate to voltage. Yeah. So when we drop it to down from this high value to low, your current goes up. That's available to you. So this domestic power unit we want to get moving in the USA is what we say a machine that can feed every component in your house and also heat your swimming pool for you. In the summer, it can cool down the room, whichever you want it to do. That is giving you the power you need. At the same time, you're cleaning, if you're using the atmosphere. And please remember that as the energy is pulled in, compressed, and put into uniform motion, it comes out as a narrow, powerful beam of electrons. Heat goes in, converted, compressed, and into uniform motion and comes out as electrical energy. So anything in the room is definitely not wasted. It is recycled and recycled and recycled, not costing you 1 penny for the amount of electricity you're using.
You never want to shut it off.
Right, you don't shut it off. You forget about it. Put it in the box, put it in the wall. Tell your family forget it, because they have no maintenance to do. There's no wear or tear involved.
Wiring lasts longer.
No, the wiring in the house is just hooked over from the box to the output of this machine. You tell the electric board you no longer want their electric supply. Please, can you remove it and put it in the dustbin? You see, with the SEG, you are in part, not them. They have been overcharging you. They have been producing immense pollution to be greedy, to get more and more money. $1 million last year is not enough for their holidays. They want $2 million this year. Next year, $4 million. The price is going to go up and up. That's why if we don't get the SEG on the market quick, it'll be so expensive to make. If we had got the support in 1946, had got it really moving to the marketplace, you would have been buying them for about £200. Today, the first ones, I'm afraid, are going to be about 16,000 from my calculations on the cost of materials. They will, when we get more production lines, the price will come down because we'll be buying a lot more tonnage of material, which brings the price down. We will try to develop cheaper materials and make them do the same as these costing materials. So given time, and we've got the technicians to spare, we'll get them on the job to look at some of the very cheap materials to see if we can. It'll be a bigger machine, unfortunately. That's the only difference to the ones we're now doing.
Could you replace those 12 electromagnets on the outer periphery there? Could you replace that with another ring, and then would it run by itself?
Could you replace the coils that's on there now with another ring, and then would it run by itself?
Yes, what we're doing, the scientists said that the rollers will not run. You cannot put a magnetic wave on metal. Since 1946, they have blocked this work by that simple statement. They said if you did get 12 to sit on there, which is most unlikely, they would jump off if you tried to move them. What we've done there is prove they're wrong, which I've been saying all these years. The rollers do stay on it, and they will speed around. The only thing I was doing was assuming how much power have to be drawn before they rotate. But I asked Morris, well, first of all, that plate and the 12 rollers were sent to Morris, bung them up, and it went to the Conference for Future Energy in Washington to show that the rollers would stay on there. That's all his intention was. And because people kept pushing them and they still didn't come off, it caused such excitement, because that proved how wrong the scientists were. The next stage, when they came back, I said to our man Morris, wrap it up and send to me. I want to find out how much power required to make them move. Oh, I'll do that for you, knowing that I was struggling on the pension and I'd just been robbed of 380,000 quid's worth of equipment containing my life work. He said, I'll do it. So he did it, and he found 5 volts, made it move. So I said to him, he rang me up, increase it by 2 more. And he phoned back to say, it's going like hell. He said, it's scary. So I said, you've just proved what I've been saying all these years. Inside the atom is enough energy to make them run. That's why they keep running, because there's so much energy in rare earths that will never stop. And of course, the first thing the motor cars people said to me, well, if you can't stop it, what good is it to us? Good. You've got an engine that's running and keeping the car warm and that, ready for hopping in the morning. Why? While it's running, it's fully loaded. So it's just cruising around, keeping everything running, remagnetizing itself, so it never runs out of the magnetic effects. You get in and you switch on to feed the electric motors on the wheel. You use heavy wire resistance to put a load to get it to move, and when you start the wheels, that put a bigger load, and away the rollers go. The rollers rotate at speed by the amount of power you're pulling. So the more power you take, the more speed. That's just one little bug. And it's this: you do not get into the system and remove the safety switch, because we are under no intention of replacing your home if you put a hole through the roof, because you overspeeded it and it went superconductor and airborne. It's a very, very costly thing to experiment with it.
Could I say then that if you put another band around it, it would run, but it would become dangerous then? Is that?
No. This is a mock-up. This is not an SEG. This is just a representation of it. It is magnetic, but it doesn't run by itself. It's impulsed from those coils around it. This is just for show. In the actual SEG, the second ring collects electrons from the rollers. You can stop me when I'm wrong.
You're wrong, you're right. What you're looking at, as I said, we are trying to find out how much voltage it takes to make the rollers move, because the scientists say you can't do it. It takes, the first one takes 5.2 or 3, about that mark, and they run. At 7 volts, they go like hell. You think there's race horses on the track, racing to be winners. So we now know how much power is needed. That power is sufficient in all rare earths. In other words, using rare earths, it self-kicks itself. It does not require an outside source. That is what we're investigating.
So the inner ring is not a real SEG ring.
This particular one? That's correct.
So the inner ring and the rollers, they're mock-ups. They're not real.
That's correct.
Okay, thank you. Question?
Here's the guy. We'll get you next.
Okay. Okay.
puts out 15 kW.
The unit that we are looking to build, which would be the prototype unit for the SEG, that SEG would put out about 15 kW at about 240. What's the maximum? What's the maximum that it'll put out?
That one, if you remove the safety switch, will go through your ceiling, out the roof, and you'll need a new house. And it will carry on up, and away.
What's the maximum current level?
The current level is proportional to the voltage output. The output for the SEG we're developing for the 15 kilowatts per home, the power actually before step down will run into about 10,000 volts. And we drop that down to the voltage you want, and that gives you the 15 kilowatt output.
What effect will the eddy current on those bearings then?
None.
With the high voltage, high current?
None. What effect will the high voltage and high current have on the eddy currents?
None at all.
None.
None at all. We had somebody here.
Is it a fluctuating DC output?
On the mock-up?
No, on the real motor, will it be a fluctuating DC output? Where do you test the
Oh,
motor?
okay. Well, what is the output on the SEG? Is it a fluctuating DC output?
No, it's AC. On the last ring, it's stable. And what you're getting is the same. It depends how fast you're going to let that run, whether it's 50 cycles or 60 cycles. Well, it could be even 144 if you want 144.
So are you pulling the power off with just a single wire, or is there a ground on that to route the
No,
power back?
on the outside, picking up the power from the SEG through coils on the outside.
Yes, for domestic use, yes, coils, just like any other generator.
Oh, okay, so you're using a magnet that impulse coil.
Right.
Yeah.
Yeah,
I work with universities and students and professors around the country, and they are ready to help with facilities and funding and students. So how do we heal the frustration and anger and ignorance that we have on both sides of the equation?
it's going to be hard to even repeat. He has, this is Fernando, he has, there's institutions that are anxious to work and help to get this developed. They have to be given the correct direction. And he wants to know how we can all work together toward that end.
Well, quite naturally, you want a lot of rings for the rollers. That's 8 segments to each roller set. And what do? Well, the 2 outer ones keep it steered permanently, so it don't fall on the ground or fall off. It guides it. The other 6 segments, it's the power horse that makes the power you want. What was that question now?
He wants to know how do we heal the relationship between you can here, come here.
I don't have hearing. Please, somebody buy me.
Right in there loud.
How do we heal the anger and frustration felt by the researchers and the universities to bring them together?
Right. Of course, this is the issue I appreciate. Universities and colleges and that have been taught that we cannot do this, we cannot do that. And this is one of those things which you cannot do. They're wrong, but if they really want to help, and I think they soon will do, then we have to cooperate. Colleges and universities can actually machine parts, rings and that, and all we will do is magnetize the actual force unit, and these would be available to any university or organization. They just get a hand press and press them. Now, I advise you not to try to make the materials yourself, because they will oxidize, and that means it's no good and you lost your money. we have to do special treatment to the elements before we make the plane. But we have to oversize them, and what we would ask you to do is, before machine it to the size we say, is to check the weight, because the density of the material is vital. If you make it to size and the density is not what we said, the firm was wrong on this density, you cannot win. There's nothing you could do. So density is vital. And we would work that all out. You get the materials, you machine it down to the size required. And if many firms or universities got their students to do it, you would be giving us a lot of rings to make many race bearings, as we call them, or we can just say roller sets. And the more we could make, the better. The plates take a little bit more time, as you can see. It takes a damn lot more power to magnetize them. But if people were making the different segments for it, then leave us to bang out those magnetic parts and ship them out, and you just press them together, we could get a lot of SEGs out. And you would feel good because you took part in it. And when you take part in something, you'll always feel good when you know the scientists are saying you can't do it, and you're proving that you can do it. That's the difference. That's the lady, you know.
Okay, one more.
One more question.
One
Go
more.
ahead.
Yeah.
Presentation, he showed us a little bit how he chooses magic square, and based on the second diagonal of the magic square, he chooses proportion between the density of the mass action square for the three rings of magnetic stuff. I've seen also that the numbers of cylinders that are turning around has a clear sequence. It's 30 something, 22, and again something. On what base did you choose the point? How did you choose this mathematics?
The squares, what you want to know, how did you choose the numbers of the sequential numbers of the line value that you're using?
Well, I've one advantage over you all. I had dreams that told me how to do it. I never learned how to do it. The dreams told me. And I just carried on experimenting what the dreams were saying and found the right face. It's a cube, but it's only one face that meets the dream. And that works perfect, with no trouble at all. If you use any other setup, it won't run. It will not work. And that's £3,000 for a bit of material.
I've got a very expensive paperweight to prove that.
And he knows.
Excuse me, John, can I break in? I'm going to explain to them our Thailand effort.
Who's going to explain the Thailand? Can't go here.
Hello? Nobody can hear me now? I need more volume over here, please. Test, 1, 2, 3, 4, 5. Great, thanks. I resigned from IBM after spending I've been working with John and the team since 1995, and I gained a lot of experience to the extent that I decided to go full-time. And I decided to work with a group in Thailand who are willing to fund the effort, provide a site. And we started back in 2008, and I'm going to share with you my experience over there, and you'll be able to get a sense of what it takes to make this project happen, okay? Proof positive that I'm in Thailand. That's the airport right there. Let's see if I can toggle this thing. Oh, okay. Here's one section of the one of the buildings where we have workers. You know, when you work on a program, you don't just start building SEGs. You sweep the floors, wire things up, set things up. It's a lot of work in reality. And you can see we got a lot of helpers, workers setting up electricity for heavy equipment. This one? Okay. Sorry, folks. It is? Okay, maybe it's just low. Here's another look. Those vertical lines are high-powered electrical connections for the heavy equipment. And that green unit there is a 100-ton press. Yes, yes. There's a closer look at it. I'll go back to the press. Back in John's day, he used powdered press materials. We're exploring solid materials to make it all more economical. There's your heavy-duty bandsaw. Oops, let's go back. Here's the framework for the magnetizer. It's a type of Teflon material in acrylic. Yeah. All right. Here's one of our Thai helpers. And what you're looking right there is the framework for winding a 300-pound coil for magnetizing the plate. And the first prototype built in California is in that suitcase right now, which is, by the way, precise and accurate to the lowest squares. The only thing that's missing is magnetization. And that requires a lot of energy. And you can see by this framework right there, that's the kind of coil it requires. That center hub area is where the magnetic section would go for magnetizing. That's a CNC lathe. When it comes to machining the rollers, there's so many of them that you need repetitive precision. And that's really a requirement in the project. Here they're bringing in heavy gauge copper sheets, which will cut to our design. Everything you see here is, as far as the magnetizer, it has to be custom made. It's not something you can buy off the shelf because nobody magnetizes like we do. You see pieces being cut and moved around. Oops, sorry about that. I don't know why it advances like that. Okay, that's an outside view. Here I went to a Thai expo where they had all kinds of wonderful heavy equipment. The only problem is it's all new and expensive, and we had to be frugal. Whoops, how'd that get in there? No. No, she's just a rep there. And that's a custom-made coil winding machine for the 300-pound coil. All right. Nothing you can buy off the shelf. We have to make it ourselves. All right. There's an area where we have the lab, and we can do a lot of work. We had a lot of visitors come in, and a lot of interest over there. This is the interior view of the magnetizer, where you can see there's copper plates inside and out. And one of our visitors there is a, I don't know if it's a nephew or something like that, of Von Braun. It was an honor to meet him. Here we're setting up the racks for the UPS, because the SEG requires an enormous amount of power for 1 second. That's a long time for magnetizing. In another area, we have the two IT personnel that do graphics and design, and that's the kind of people we need, is to work on that facet of the effort. All right, it's our meeting room. I'm not sure what I'm pointing at. Typical meeting here. Visitors. even had the Prime Minister of Thailand. A lot of notable individuals have showed up. In the background, you see the control panel and the magnetizer, and further back is the rack of UPS batteries. You see more heavy equipment being wheeled in. That's a CNC milling machine. More sections of the magnetizer. It's all coming together there. There you see the bus panel for the type of currents that we'll be dealing with. All right, another view. Oops, let's go back. Those are the basic sizes, materials to make the prototype, which you'll see in that suitcase right there. All right, well that's it. I didn't have a lot of time to put this stuff together, but I hope it gives you an idea of the type of work it takes to get this thing done.
We are running close to the end. We have to catch a plane very soon. So I'd like Ross to give you a brief on the model he raced up in a few days. So we had something to show you what his work relates to. Ross, will you take the ammo?
Thank you. Thank you for.
Mike. John, Mike. John. Mike. Handheld.
You got it.
There we are.
Thank you, Professor Searl. I just want to say what an incredible honor it is to be on stage with you and be working with you on your technology. And we're going to take it forward. Anyway, my interest and my expertise is the flying disc and electrogravitics in general. I'm the CEO, owner of Applied Electrogravitics, and I've been studying John's flying disc and IGVs since the mid-1980s. And basically, I made it my business to learn as much as I could about the technology and why it flies and how it works. First of all, I must say, I'm going to walk over here to the model, that the SEG, the Searl effect generator, is the thing that actually flies. The disc body is a flight frame for control, because without control, just like the first 6 units that were financed by George Haynes, it will fly off into outer space at incredible speed, overloaded on the atmosphere, and be lost. Anyway, this is a flight frame for control. The dream tells you the parameters. Dream number 2, there are 2 dreams. Dream number 1 is the SEG. Dream number 2 is the IGV, or flying disc. The dream basically tells you the parameters for building this craft. Now, obviously, the ideal shape to contain the SEG is a disc. After all, what are most motors and generators? They're round. They're round. Now, this SEG in here is allowed to overload via the flight cells. The flight cells contain a load cell, basically pour the energy from rim. I didn't put rim projections, rim discharge pins on the outside, but there would be adjacent to each of these 64 flight cells. By the way, the IGV has 64 struts. There will be 64 flight cells, which are just allowed to, I don't know if the camera can pick this up, snap open and closed and rotate from 0 degrees to 90 degrees. And there are a couple different things that happen. What happens is a gyro control. You control it by hitting it or touching it. And the 1/64th of the circumference of the disc is forced to drop. Now, on the P11 and other previous models, the control was not as fine. You have to activate banks of flight cells. And each of these 64 flight cells is controlled by an individual radio control channel. Now, of course, today we have much better radio control, much more powerful. I don't think there's any need anymore to control it on 12-meter ham radio as it was in the past. But the future now is to have manned units. Now, what happens, what makes it go up, is basically the Earth repels it with irresistible force because of the superconductivity. The voltage streaming off the rim, and well, you know from physics that electrons, high voltages, like to adhere to rounded, smooth surfaces. Think of the terminus of a Tesla coil or a high-energy Van de Graaff generator. But electrons love to eject from sharp points. So we have a sharply pointed rim, and we enhance electron ejection by having those rim discharge pins adjacent to each flight cell, and we have a flame barrier. That's very important in the construction too. So we have 64 struts, 64 flight cells, then we have an upper shell and a lower shell, and those are normally charged and uncharged. Now, those upper and lower shells are normally connected to the innermost positive ring of the SEG, which is on the inside of this SEG housing here. This ring that you see running all around, we don't have a top and a bottom on it, is the SEG housing. And we want that near the rim for proper control. Now, the flight cells are adjacent to the outer wall of the SEG housing, and inside each flight cell is a solenoid, either electrically activated or we can have redundant systems of hydraulics to fire a pin once it's activated, fire a hard rubber pin at the outer roller just passing so it doesn't damage it. And by the way, I want to say at flight voltage, it's some 10 to the 12th volts. I don't think they were able to measure how high the voltage went, but I guess that's 1 teravolt, and the current level, what is the current level, John? 1.5 milliamps? Yes, Jonathan, 1.5 milliamps, so that's high energy electrostatics. And we know from the unified field theory, 1929 Einstein, Takaki Musha's paper on the possibility of a strong coupling between electricity and gravitation, and also Tesla's new Tesla scale electromagnetics, that high energy electrostatics is identical to a gravitational field. So what we have on board the IGV is 1/2 G gravity. So if you weigh 200 pounds on board the device, you only weigh 100 pounds. Anyway, what happens also, I didn't get a chance to explain in the first talk, is that you have also 4 switches on the inside of each flight cell that are activated to switch the energy on or off between the upper shells and the lower shells. And those are, of course, electrically isolated. Now, to change direction, we also employ the Biefeld-Brown effect. Now, back in the day, Professor Searl used to make many of these units uncontrolled and just send them up, and the neighbors would see them, and they would be called electrified butterfly nets, which is an interesting terminology. And later on, John wanted to see what role electricity played in the lift. So he made basically a T.T. Brown bed strings device and energized it, and of course it rose up and degravitated. One paper that I came across in my research was a paper by French aerospace engineer and was granted the patent, Marcel Page, Dr. Marcel Page, where he states that if you have a body and extract a charge of electrons from that body, and that charge of electrons is allowed to rotate around that body will degravitate. And we have about 3 or 4 different kinds of force fields involved around the IGV. We have a very high energy electrostatic field coming off the rim. By the way, that electrostatic field will repel all matter that approaches the rim. So if you're in space, you're traveling very, very high velocity, the ship's skin won't be penetrated by micrometeoroids. They'll just be deflected. They'll just be running out of time. Anyway, the bones, because of the onboard gravity, the bones and muscles and joints of astronauts will not degenerate, because they'll be under gravitation. And also because of the integral field, you won't have to suffer radiation in outer space. Cosmic rays will probably be just sucked in and used by the drive, but you won't be affected by it. The beauty of the IGV is that it will bring the cost of space work down by vast sums, vast amounts. So the very fact that NASA, the Russian Space Agency, are spinning their wheels at this point, they're not getting anything done in manned space, is directly due to the technology that they're using from World War II, which is a flying fuel tank. This device uses no fuel. You don't need it. All the power in our universe is utilized by the drive, a constantly expanding flux. So what we have basically is a beautiful machine. Instead of a vertical concept of a flying fuel tank that can explode and kill good people, we have a much safer device that is yet more powerful. And the thrust from this thing and the force is unbelievable. At that flight voltage, the runners are running around the 3 plates at incredible velocity. You see a pink halo adjacent to the flame barrier. That's like a laser pulse. That's not an ionization. I'm informed we're short on time. But I'm free for any questions and answers afterwards. Thanks for your attention.
Thank you all for your attention, and we have run out of time. We've got to rush and catch a plane to Glasgow, Scotland, to get prepared for my lecture at the Leeds University on the 7th or 8th of the month. I'm sorry, we would love to stay and talk longer, but I hope we shall meet again very soon. And that time, we hope we have far more demonstrations to show. And I'm certain you'll be amazed how and what you can do with magnets. I would like to ask you all to join in hands to Old Lang Syne. Do we have anyone who could sing? Because I don't think we got the record. Please, can you?
Russell, you can sing.
Can we stand and hold hands?
Come on. Come on, then. Come on. Come on, then.
Everyone who can
good
sing,
voice?
join hands and
Come on, then.
come on, let's make it a farewell do.
Linda, Russell, lead off.
Should old acquaintance be forgot and